Now it's better. Just everything is nucleus. That's how we run the pixel classification. No, we specify more background, more background, more background. Yeah. You see. And again. Now they are all nucleus. And you can run the 2D recipe with it. Let's see. This again, review. Now we're thresholding with this pixel classification result. Done. Okay, much better than before, right? Okay, this is why we should threshold with the pixel classifier instead. Like this one. Okay. This depends on the quality of the pixel classifier. But it should be easier than color threshold. If you use color threshold, if this guy has a very similar color as the background, you'll pick up the background as well. But they have different shape. So the pixel classifier is able to pick up the details. So this is 2D, and 2D we have something like nuclear count, which is very similar to the cell count, but the name is different, just nuclear partition. So you can see threshold, field hole, smoothing factor, and separation factors. So this is all very similar. But for cell count, the very basic type of cell count, we have nuclear count and cell count. So 2D analysis with the pixel classification result. And you can apply, let's say I change some of these settings. You can apply, let's say I've stored the parameter settings within the object, within that object set. That means I can record the parameter I've used previously and then apply them into AIVIA. And you can click and use the recipe setting that create this result. Let's say I mess up this a bit, or 0. And then I can click this icon. And now they return to the previous setting. I mean, these are the settings that generate this result. So I can record the setting. So if you save this image, save this image. Oops, exit. Yeah, let's rename. And then close it. Next time when you open it, you will have the object set stored with the raw data. So everything we've stored with it, you have the raw image, your object set in here. And everything within the spreadsheet will be stored with the AIVIA TIFF. So this is basic 2D cell count. And if we want to run 3D analysis, we need a 3D data like this one. So this is a Drosophila embryo. So 3D data set. And then you can go to the recipe console again, and then select 3D. So we have 3D analysis. We have 3 recipes, but they are doing the same, almost the same things, but slightly different. For this one, 3D object analysis methods, that means the software will generate a mesh or a model around the detected object. This is 3D analysis of meshes. And for 3D object analysis spots, that means the end or identify the 3D object will be displayed as a spot. If you are not interested in the morphology of the target, just the location, you can select spot. Okay. So this one is a little bit different. This cell pulse. This one is combined with the deep learning, a model trained with deep learning. And this is cell pulse. And we combine, especially to identify cells. So if your background have a very strong background, if you don't want to run the pixel classifier, you can run the cell pulse. Because the cell pulse, the model is trained with, let's say, thousands or tens of thousands of data that actually it knows what the cell looks like, so it can pick up the signal from a very noisy image. So this cell pulse, but I will start with the simple one first. This is a 3D object analysis methods. So again, it supports a single channel only. So original, so the channel name is here. Original single channel. And again, you have the ROI tools here. If you want to speed up the preview, you can use ROI. Click here, and same way to define the ROI we have seen in the pixel classifier, but now this recipe has a different ROI as the object classifier. So we can use the ROI within this recipe. But remember, if you want to use the ROI, check this box. If you selected to display it, you won't use it. You visualize the ROI, but not to use it. Check this one, and then tell the software that you're going to use the ROI for image analysis. And first of all, it's a detection. And you can apply some kind of smoothing filters on the 3D object if you want to do this, to make it look smoother, but I will disable it first. Just skip it now. And then this is a very simple intensity threshold. And then we switch to 2D view. And here. Okay, I will enable this display preview. You can, now this reading is now 8,000. You put your cursor on top of the image, and you can see in here the intensity of that pixel. It's around a few hundreds, just below 1,000. So we have nothing here. So I just say 500. And then we said it's generating preview. Now we have something here. It's threshold. This is why we need to use a pixel classifier for the reason, because of this. But I will just give it. We can run it later, but as you can see that the signal to noise here is not good, and the software pick up some background as the signal. So we can run the pixel classifier, but I will just skip it for now. But so we can increase the threshold, let's say to 600, and see what will happen. Something like this. So now we miss this one here. We will keep 500. Now, is the preliminary threshold result. And then we will see, let's see over here. These two objects joined together after the threshold. And then this is why we need to apply the partition here. And first of all, we can do two things with the partition. We can filter them by size. But remember that we have two display preview buttons. If you click the upper one, it will just show you the threshold result. If you click the lower one, it will show the threshold result plus the partition result. And now set to 20, it just filter out some smaller object. Well, reduce it to, let's say, 10. More, maybe 5. Or you can measure the size of the object by clicking the annotation. Here, you can draw a line. And then you will know that slightly below 5 micron. That's why when we say at 10, the software will filter out the smaller object. So I'll keep it at 4. Okay, done. Now it's just filtered by size, but and then the mesh smoothing. Let's preview in 3D. Now we see that the object looks very pixelated because we have 0 smoothing here. To smooth the 3D model, we can, let's say, increase it to, okay. We lost the connection again. It's now it's 1:2. It looks smoother than before. Okay. Yes, but remember that if we use the smoothing, it will slow down the image processing because you need to calculate the interpolation between 2 pixels. So if you use more smoothing here, it will slow down the image analysis process. If you use a very high number in the smoothing, in the measure smoothing, it will also lower your measurement accuracy because you just interpolate, just make a, let's say, let's say an object with some angle, maybe that object with certain angle and pointy, but if you use a high number smoothing here, it will turn the object into a completely round shaped object. So it will use the measure smoothing with caution. And then this is the most important part here. We call it, we're going to apply a watershed filter on the object. As you can see, we have 1, 2, 3, 4, 5, 6, 7. We have 7 nuclei here. They joined together after the threshold. And then we're going to apply watershed filter to split them up. Remember that we can use the apply partition. And now mean edge to center distance. That means this is from the center of the distance between the center of the object and the edge of the object. So we have measured it before. Length is like 5 micron. So half of it would be, let's say, 2 to 3. I would say 3. Now we have separate all these 7 nuclei. If we make it bigger, like 10, it will join up. There. So it's related. If you set it as smaller value, the software will give more object with a smaller size. So this is partition. Yeah, the partition is pretty good right now. So without the partition, it looks something like this. So I'll turn off the partition. Yeah, they're now joined together without the partition. Now apply the partition with the mean edge to center distance set to 3. So they are now separated. So once you're happy with the settings, you can run this 3D analysis module on the whole image. So now I will disable the ROI and then apply it, start. It will take some time. But oopsie. I think it's utilized like more than 10 CPU core depending on the PC configuration. Yeah, this amount not just one layer, it's 3D. If you preview it, that ROI is in 3D. If you apply this setting, the preview is generated in 3D. I will show you later. But this is 3D. It's applied to 3D. You can check it you can check it in 3D. Just enable the ROI and then go to 3D, click the preview, and then you can check the partition in 3D. I was totally dependent on the CPU. Maybe next time we use the ROI. Yes, but just ignore this one. I will turn this off and then go to the preview again to turn it off. So if you click this one, you generate the preview with these settings. Now you see that you can preview it in 3D. So now in 3D. You can, if I disable the partition, and now you can see that all of them will join together. Yeah, like this, single large object in 3D. Just a few 2 to 3 objects is detected here because they are all joined up together after the threshold. And then once you apply the partition, let's say I set, and now it's split up together into a lot more objects. So this is actually applied in 3D. I mean the partition field. But you can check the result in 2D. Yeah. So in 2D. This is in 3D. Okay. And now we have all the cells detected in the. This is just, if we go after the image analysis, if we go to the object set display settings, we have the object meshes and cross section. Meshes is 3D, we call it meshes. Our cross section is this one. In 2D, this is called cross section. Okay, so they have different names. This cross section. This is meshes. Okay, if this is displayed in 3D, again, disable the ROI first. You can change the color. The color of the object. Again, if you want to display the 3D model with the measurement result, it's possible. And now the color is now related to the measurement. Okay. And then you can change the 3D visualization method with oops. I need to call it again. 1 second. I will change. I don't know why when I log in again, they change the layout, but I will change it again. Okay, now we have this 3D model. And then you have in the object settings, you have the view view icon here. And now it's solid surface. So it's solid surface. It looks like this one, solid surface. And then wireframe, it will zoom in, they will display the wire instead of a solid surface. And it's potentially can increase the performance because they are not displayed in full measures. Or you can choose point. If we zoom it out, they will display it as a 3D object. When you zoom it in, they will display it as point. So 3 different types of 3D visualization with the model. Solid surface, wireframe, and points. And then we have more. We can do more with these 3D models. Remember that we can do 3D oval scan and clipping with the 3D model. But after we have this 3D model generated, I mean 3D measures, we can clip not only the signal, but also the 3D model. Add a new clipping thing. See that they have a measures icon here. We can unclip it. We can just clip see that. Now only the 3D model is clipped, but not the original signal. This is a tool that might help you to check the accuracy of your measurement. So you can overlay your 3D or the original signal with the 3D model generated by the 3D image analysis. This icon here. If you disable it, you won't clip anything. You enable it. It's now clipping only the raw data, but not the 3D model. And then we can do a oval slider. In the oval slider, you can also overlay your 3D model with the original data. So you can validate your analysis result. Okay. Okay. In this oval plane, you can change the thickness of the section. Now 5 and reduce it to, let's say, 2. So you can see a particular layer. In here. So this is more about the 3D options once you have generated the 3D model from the result. And we can go to the spreadsheet and check the data again, same as the 2D analysis. We have the measures and cost section. And now checking the measures, that means the data is 3D. We have volume. If we go to the cost section, we don't have volume. So normally we run the 3D, we want the 3D data. So it's measures, surface area, etc. And then you can enable more by clicking this icon here, measurement. You can enable more. So this is 3D. Any question regarding the 3D? Simple. Let's enable everything. Well, let's to change the layout back to here. This better. Okay. So after 3D analysis, I can introduce another 3D analysis like application. We call it 3D tracking. So we can track the object in 3D. Now I need to change the data set. So this is again a 3D object data set, but with time lapse. If I want to track it, I will use the 3D tracking. Where's tracking? 3D tracking, object tracking. We have a lot of tabs here, but they actually looks identical as the 3D object analysis. We have smoothing filter, mean edge intensity, partition, filter the object by size, and then this is the watershed filter. It all looks the same, but with one additional panel here, we call it tracking. So we can track the speed and the movement of this object. And remember that the input, we have to specify the input. If we have multiple channel images, we can only track one channel, a single channel, not multiple channel. So now it's GFP, the channel name is GFP. And then again, we need to do the threshold. I think it's too much. And then check the intensity first. Over just 100. No wonder why we have not many here. Just 100. We are disable the filter as well. Yeah, we have it. See that? This after the thresholding. So we have all these objects detected. But again, they look very pixelated, pointy, because we didn't apply any smoothing here. And then we go to the next step, partition. First of all, set the size filter. If you set something like this, from 0 to 1000, that means you're going to pick up all object detected. No filtering. Let's say if you select 1, 2, anything smaller than 2 will be removed from the calculation. And then we apply the smoothing. Now looks better. Looks really smooth. This is without any smoothing. Yeah. Looks really pointy. So we apply 2 in the object smoothing. And then we can see that the object joined together. We can separate by applying the watershed filter. Again, this is a mean edge to center distance, do some measurement. Or not. We can guess the size of this object by the scale bar. It's 2 micron, around 2 micron. So we take 2. Maybe 3. Yeah. Something like that. But they are mostly separated, except this one. There. No. So if this looks okay to you, we can go to the next step is tracking. For tracking, we have a number of parameters. First of all, the mean track length. Let's see if that object appear in the data set for, let's say, shorter than 2 time points, the object will be moved from tracking. We won't track any object that span less than 2 time points in the data. So let's say the corner just appear like 2 time points, we will omit it. If you set it at 2, we can set it more. And the next one is the max search distance. And in tracking, we have to correlate this is search window so that we can link the object in different time points. So we can, if the search window, this is 5 micron, that means if this object move, let's say 10 micron, then we regard as 2 objects, because that 2 objects, it doesn't within, I mean, it's longer than the search window. So let's say, just make this easier. For time point 1, the object 1 is here. If you set the max search distance at 5 micron, but if that object travel like 20 micron in a single time point, that will be counted as 2 separate objects instead of 1. So there is no track line between these 2 objects. So this is search window, but you can set it longer. But if you set a very high number, let's say like 20, anything within that search window may confuse the algorithm. Let me count it one, maybe, let's say time point 1, we have 1 object in the search window. For time point 2, we have 3 objects in that search window. The software may track it more. We make a mistake in the tracking because we have more than 1 object in the search window. So set it like, normally I will drag it and see how long that object will travel for a single time point. So make a guess, like we will disable the preview, check the fluorescent intensity, less than 3 micron, I would say, 10 micron, maybe or even 2 micron. So we select 3. And this one is tricky. We have motion versus intensity. What does that mean? And I need to make some drawing here. So we have motion versus intensity. So for example, if we have 2 objects, oh, sorry. That 2 objects, this is time point 1, time point 2 object. If we select motion, just drag this line all the way to the left-hand side. The software will detect the motion of this, prioritize to detect motion instead of intensity. That means if this object is moving in that direction in the previous time point, the software will count this object as this one and this one as this one. So it will prioritize to track the motion instead of the intensity. That means in time, this is time point 0. At time point 0, that object is here with more. That means this object is moving in this direction. So they have a cross here. We will predict this object is belong to this one. And this one belongs to this one because of the previous time point, the motion. So if you select intensity, so the object, this object and this object have a similar intensity, and this one have another intensity, the software will track the length in this direction. This one. It will depend on the intensity rather than just the motion. So if you set it in the middle, we consider both the intensity and the movement of the object in the previous time point. So it's 0, 5. So it's track the object with like motion and intensity strategy, depending on the data set. Okay. So track lineage, if you want to track the cell division during the tracking, you can do so. But I think we don't have any cell division. We can do it. We can track the lineage. And we have two algorithms, greedy and Hungarian. The greedy is faster, but the result is less accurate. For Hungarian, we have this is slower, but more accurate. So it depends on your need. Hungarian will consider the motion of the object in a global manner, while greedy will just the local movement of the object. So it's less accurate, but faster. So we choose greedy. Done. I will click start. We'll do the tracking. Where's my object data set? It fails because something is wrong with my partition. Okay, do it again. Oops. Just one moment. Max search distance. The one on is 5. Is that wrong? 2. We do it again. Now it's tracking, and you can see the tail of the object. And then we have the object set settings after image analysis. The track is 5. That means you are showing the track length for the last part, for the past 5 time point. You can select 15 because we have 15. 15 time point, 16 or 16 time point. So this is a trend. That means the object is moving in this direction. And the anchor is actually the center of mass of the object. If I set this object to a transparent, increase the transparency, and then you can see that this is the center of mass of the object. So we have both track length and trend enabled. This is, we have set it at 5. That means over the past 5 time point, this is the track of that object. You see that? Here. And then in the data set spreadsheet, we have speed, direct line velocity, acceleration, etc., speed related parameters. Also the volume. And then if we select track lineage, we have an additional track editor. So you can see that if there's any like cell division, you can see in here. Okay, you can edit it manually. Just link it to somewhere else. Like this one, you can join them. You can manually edit the track length if you have the time to do so, but it's a very tedious job, I would say. And I'm sorry. Oops. If you want to take a snapshot of this track editor, you can click here, this one. Copy the entire track editor panel with the current one. Okay. Copy it and then we can paste it in somewhere else. Yeah, you can paste it somewhere else. You can, let's say, do some manual editing job maybe at time point 12, I think this is actually two objects you can disconnect from here. All sort of manual editing. So this is and then in the chat window, okay, this is a check to display the information of the parameters we have generated in the spreadsheet phase. If we select, let's say, the intensity or volume changes over time of that particular object, this volume changes over the 16 time point we have acquired. You can change different parameters according to your experiment setup. Like this one, you have a lot more or surface area intensity change over time. This is the chat window, and you can export the chart to a diagram file, or you can copy the chart to clipboard and then place it somewhere else, like here. Or you can copy the chart data to the Excel. You can put it again if you don't like this style of graph. So this is tracking, very similar to 3D, just we have one additional tracking panel. So I will tell you more about the cell pulse. That time point, for that particular time point. Yeah. Yeah. Detect we do the 3D analysis first, detect the center of mass, and then track according to the center of mass. So I assume that will be kind of like pH, but then after it pieces, then that will change. Like these two objects. Yeah. Yeah. Overtrain. We detect another object, a new object. As a new object rather than because from, let's say, time point 1, this is a single object, and time point 2 it divided in 2, so we count as 2 different objects, so 3 different objects. Yeah. The big one just disappeared. It's connected, just like this one. We divide, no longer track 6 just disappeared. We're no longer counting track 6, but we have 2 new tracks here because they are from like cell division. Okay. You can join them. You don't think make some mistake with the software, you can join them. Let's say hello. And join them to another one like this one. They create lineage. Yeah. You don't think that cell is not divided from that cell. you can create that lineage to another cell. This is completely manual editing. If you want to edit it, you have an option to edit it manually. But this is the auto detection result, plus an option to edit it. And then the cell pulse, or maybe not the cell pulse. I will cover the object classifier first. We have the pixel classifier, and we have another classifier we call object classifier. Layout. So I mentioned something about the layout. If you want to change the layout of it, you see that some windows is now missing. let's say the object set setting is missing because I clicked something wrong, mess up the layout. You can always enable the window by clicking this layout. Let's say now if we don't have the 3D display option, we want to enable it, click it. Now the 3D display option is enabled. You can put these windows in different area. If I want to put it just next to the channel display setting, just drag into this area. Here. Now the channel display settings is placed next to the 3D display windows. And then, so we can classify the object according to the measurement. So it's actually, this algorithm is still machine learning or random forest, same as pixel classifier, but we are going to classify the object, but not the pixel. But the object classifier is missing as well. The object classifier is here. Go to layout, enable it. I don't want this window in here, so I drag it. Here. Yeah. So it's not object classifier. We have generated like something like 2,500 objects. So we want to classify them, let's say, according to their size. So we use the object classifier. In the object classifier, here, you create a new classifier. Of course, we use the meshes instead of the outline because it's 3D. So mesh, create. Now it's 2,500 objects in here. And then you can, same as the pixel classifier will create two classes. Let's say this is the small one. Right click on it, rename this is big one. And then we can go to the this small one here. I go to the model. Okay. Select this one. Now selected. I will classify maybe a small one. So I will click select here, small, we'll click assign. Now we'll see that this object is assigned to small. We can pick another one. Okay, this one is I don't know. You just zoom in a bit. Yeah. Here, you assign to small as well. One more. Assign to 3 example. This was big one, so I will assign them to this is wrong name, but anyway, big one. The huge one. So we have 3 examples for each class. So now if you have an additional option here, we call detect novelty. The pixel classifier will try to divide all these 2,500 objects according to the example I provided to the object classifier. But something, if the software detect the third class, if you enable this one, detect novelty, the software, if the software finds something that cannot be classified into these 2 classes according to the score, we call it novelty score, the software will create a third class automatically and tell you that you might have to look into the data and see if there's something special. Okay, this is detect novelties. So click teach. Green, that means accuracy 100%. That means the object classifier is healthy. You have provided enough information to train the classifier. And basically, the classifier, the information is, I forgot to select here, but I will show later. And apply. Now divided into 2 groups. See that? one big, one small. And if I create a classifier again, in new classifier, you can specify the measurement. Let's say I just want to use volume. Where is the volume? Volume, just volume. I want to use the volume to classify the object only. So it's how you create the object classifier, or the intensity, or more. It depends on your just the choice. Or if let's say you want to track, you want to divide these cells according to the shape, you can take this one, volume plus how round they are, and then you can create, let's say, two classes. This is like class one, and class one. This is class two. We want to change it. Class two. Okay, teach it again. Apply. Oh, we remove. Yes, please. And then we have two classes here. New classification one, classification two. And then we can use the color to separate these two classes. Remember that we have the matrix viewer here. Go to here. We select by class. Now two color. This is a small one. This is a big one. So we use to train the classifier to separate the 3D object into two classes. Same. Yeah. Door object. I think it's from the previous result. I forgot to delete it. Yeah, we don't happen. No. The lawful score is maybe this the threshold is too high, too low. I mean, it depending on the threshold. Here's the threshold. We'll do it again. The threshold 2.9. Yeah. We can check the lawful score. Very high. We will check their score as well. That means the data here is not sufficient. Yeah. You have to find something in between. There's something in between. That means I didn't provide enough training data. Yeah. Just free. Just free. Maybe we need more. If the software found something in between, something middle, it's just don't know where to play. That means you need more training data. This is the object classifier, and then you can save your object classifiers. Save this classifier. You can use it later. You can maybe delete it, and then you can load again. Load classifier, and then you can load your classifier. This save and load. Any question regarding this one? Yeah. Oh, it's blocking required for the image and our computer. AIVIA installed. Oh, this. Oh, the answer some of them already. Which one? Which one? Regression also. You may regression. You elaborate how you elaborate how maybe regression. And in the afternoon, we are going to cover. We have covered 2D analysis, 3D analysis in the morning. So we are going to cover 3D cells, 2D cells, and the neuron model, plus the cell pulse. Yeah, maybe some kind of batch processing. You have it. You can include everything in your packet. So we'll cover more in the afternoon, like this one. Cell analysis, either 2D or 3D, is different from 2D object detection or 3D object detection. In cell analysis, you can count, there's a different vesicule within the cell and try to find a relationship or the distance, let's say distance between the membrane, the nucleus, and the cytoplasm, and if they have any colocalization. So, but in 3D, you don't have this kind of data. But if you want to find the relationship between, let's say, multiple channels, you need to use 2D or 3D cell analysis. They're different. So it supports multi-channel. So we'll cover a bit more in the afternoon. And the cell pulse is very important. If you're working with cells, you might need the cell pulse to segment the cells, give superior result to the traditional thresholding technique. And somehow the accuracy maybe over 90%, 95%. So this is what the cell pulse does. And this is something we are going to cover in the afternoon.
I'll see you guys at
In the afternoon.